I tell you, where's this scene? And math students, it's time. It's time. Look upon your neighbor and say, hey, time to go, boy. Time to go. So I know you have some students, some class students all over the streets. I really wanted to do a kinematic session. I wanted to do it last week, but we started the math sessions, so I'm squeezing it in this week. So in this session, what we want to do is like understand the ins and outs of kinematics, what it is CXC wants you to know in AdMaths for kinematics. So the amount of people doing AdMaths is not huge compared to maths, but you know, it is one of the toughest topics that you could do, subjects that you could do for CSEC. So we want to show it a little respect and thing. So one of the subjects that I teach every student up to. So Basha, good to have you here. We'll just hang around a little 1 or 2 minutes just to make sure everybody touching, because sometimes the notifications will take a little while to go out. So let's make sure everybody who wants to be here is here, so they should try and catch the beginning. So you would know the history of kinematics is not too long ago. One of the last syllabus in ZXC to change recently was AdMaths. This was one of the last syllabus to change not too long ago, 2022, somewhere around there, the syllabus switched over. So how many of you, when you do the past papers, when you're doing the past papers, how many questions you see in the past papers? We're starting shortly. I just waiting for everybody to touch down while we talk about what's happening. When you watch the past papers from like 2018 and thing, how many questions do you see? Good evening, everybody. Monique, Aniza, Leo, Josh. Good to see you here. Josh, Harry, Narayan, Norvin. This is AdMaths. This is not normal CSEC maths. If you're doing normal CSEC maths, just leave. Just leave. Don't do yourself that. Hi, Lini. Hi, Lini. I hope everything was good. I see new private candidates chat pumping. I hope you get through. So how much questions are there in the past papers? You usually no, they do a past paper from like 2018 or 2019 in AdMaths. How much questions are there? See the number of questions. How much questions it used to have? It used to have 8 questions or so. I find nobody answering, so what really happening there? Now, yeah, Caitlin, it used to have eight questions, 8 questions. And how much it have right now? So it used to have 8 questions, and now it switched over to the new syllabus. But now it's 6. Very good. And I don't know if you knew this, but they were divided into sections, and the last section was 2 questions, and you could have picked AdMaths. You could have picked whether you want to do kinematics or statistics. So now that's out, and you have these mandatory questions to do. So question 6 is like a really long question where they have probability and statistics snuck into that. And in question 4 and 5, they have the calculus part. And they kind of cram. They didn't really remove much from the syllabus. The biggest thing they remove is the functions. Functions is out, and it don't matter that functions is out. That was like a free max you used to get in your AdMaths paper, because you had to learn functions anyhow for maths, for normal maths. So now that they remove all of this stuff, they're still keeping the hard part of functions, so like completing the square and that kind of thing. I need to know that. They switched it up, but they didn't remove kinematics. Kinematics is still in the syllabus, so don't ever think that. The kinematics is still in the syllabus. So is it possible to finish an AdMaths paper before the time finish? My teacher told me no one in school was able to complete an AdMaths paper. And of course, you could finish an AdMaths paper before the time finish. You're supposed to be doing that by now. I mean, you'd be biting for time in AdMaths, but you're supposed to be doing that right now. So what they do, yes, that is true. Cyan, they usually bring the kinematics easier now. because they kind of snuck the kinematics in, they tag it along in the differentiation question and the integration question, because they kind of squeeze in a little kinematics idea there. It just takes up piece of the question now. So it's not like a whole question for itself. So I believe it was 2014 or 2015. There's a super long question on kinematics, crazy question on kinematics earlier. And you could check the past papers. That's like the worst case scenario for kinematics. And you have to draw a graph and you have to find the missing letter here. T, I did it with my class. That question is crazy. So because of how much because of how much time because of how much marks, sorry, is allocated to kinematics right now. Because of how much marks is allocated to kinematics right now, it's hard for them to squeeze in these monster questions again. So those of you who did this question and you understand this question in kinematics, you're probably on your way to scoring full marks in the kinematics. So now that we have mostly everybody here, let's talk about what kinematics is about. So kinematics is really tying is a blend of motion graphs from maths. And you know about the speed time, we'll use velocity time since we add maths. And you know about distance time, but we use displacement time graph. And let me do pass slash, let me put versus time, and displacement is usually S or X versus time. So it's a blend of that, is a blend of, so this is from normal maths, is a blend of physics, V equal U plus AT, those kind of things. Those of y'all who doing physics, you all know about that. Like final velocity, initial velocity. Some of the ideas of that kind of show up here. Acceleration is the change in velocity over the change in time. Some of that idea is kind of mixed up in this. That part of physics. What else? There isn't too much of like the V squared is equal to U squared plus 2AS. You don't really see them kind of horrific things happening. But some of the ideas, some of the general ideas of physics where we don't use scalar, we use the vector quantities in motion, that is tied in into this. As well as, of course, the admaths part of it, where we're going to tie in calculus, differentiation, and integration, right? So let's look at some questions and you all will begin to see the patterns. You all will begin to understand what kinematics is really, what they really want you to do in a kinematics question. Let's go and look at some questions. So what is this question I have here? I have May, June 20, 18. Did I do this in class already? Hope not. So what before I do the question, one of the recurring ideas in kinematics, come closer to the screen, lock in everybody. One of the recurring ideas in kinematics is that you could go down differentiating or come up integrating. So either integrating or differentiating, let's just use dy dx to represent differentiating. And you could go down in complexity, come up in complexity, meaning, here's what I mean. You could start off with like something involving displacement, which is like S or X, and you could differentiate, let's call it X then. You could differentiate that displacement dy dx dt. You're always differentiating in terms of time. So it's like changing distance. I don't want to get too confusing. I want to keep it simpler all through today's class. So remember, differentiation is just micro change, right? So like the change in, if I tell you the change in distance and how long it took, what am I talking about? The change in distance over the change in time. Remember, differentiation is just the mathematics of change. So if I'm talking about how much I'm changing my distance with respect to time, that's clearly V. That's velocity. And then I could differentiate velocity with respect to time one more time. So I do, pun intended. So if I differentiate velocity with respect to time, I'm adding on a next time on the numerator, next second. That's how fast I'm changing my velocity in terms of time. One moment I was driving at 80 kilometers per hour and I speed up to 90 kilometers per hour. That is definitely acceleration. And we could see it happening with the units. We could see it happening with the units. Units is meters for displacement. Then you go meters and you divide it by seconds, meters per second. Then you go meters per second squared. So far, we're keeping it simple. We're keeping it simple. You're understanding in theory that's saying. Don't try to go too deep into it. Just take the surface levels of what I'm saying. So this is meters per second squared. And what we're saying, the opposite, in our mind, we think like the opposite of differentiation is integration. So watch this, watch this. If I integrate now, if I start off with acceleration, and then I integrate the acceleration with respect to time, I back down to velocity. And then if I integrate the velocity with respect to time, I'll end up back down to a good friend, displacement. So that's like one of the main ideas, recurring themes that you see coming along in this. So what's going to happen with you in the AdMaths exam is next week. What's going to happen with you in the AdMaths exam is one part of kinematics will test this, part one, and part two will probably test this. That's how it usually works. And part two is usually about a particle. It's usually a paragraph, blah, blah, blah. Part one, they love to involve the idea of graphs. They love to involve the idea of graphs. So this is how kinematics should be stored in your mind when you're studying, right? It's like you're going up and down this differentiation thing. All right, so let's look. So when you're seeing the questions, try to think which style of question is this? Is this one where you're integrating and you're going back up? Or is it one where you're differentiating and you're using graphs and that kind of thing? Because like one of the two is going to happen. So in 2018, we had this question here. So which style is this? This is a particle. It moves at a straight line, so its distance is s. After t seconds measured from a fixed point, O is given by the function s, its velocity. And so it's a kind of weird mix because you're talking particle, but this function is in terms of displacement. And now we want to find out velocity. So what you're feeling in your heart, people, what you're feeling in your heart, let me make sure this camera is following me. What you're feeling in your heart? What you're feeling like the logical thing is to do in that situation? That's not why I just fixing this AC stressing out whole week. Whole week, boy. Behave yourself now. You're feeling a differentiation, right? Because you start off with a displacement here, and they're asking about velocity. So you're thinking displacement, how do I reach the velocity? Remember, you're going down the differential. You understand how it helps to kind of structure your thought behind this? I start off with remember I told you sometimes instead of x, they'd use s. So we want to differentiate the function and hope for the best. So let me differentiate. We have s is equal to t cubed minus 2t squared. You must know how to differentiate here in this stage in the game. This stage in the game, you must know how to differentiate, right? I hope I'm speaking to people who know how to differentiate. So here's dt is going to be 3t squared. Remember, this drops by 1 and this comes in front. This will drop by 1, this will come in front. So you'll end up with 4t plus this will just turn to 1 because this is like t to the power 1 minus 1, you end up 0. So this is just 1 and differentiate a constant and it go on. It go on. So what happened in here? We differentiate and we got this function. It's a quadratic function. But don't panic. Stay focused. stay focused on the prize. We want the velocity, more information was given. When the time is 2, we have a function here, we differentiate it, so this is also true. This is also v. ds dt is the velocity. Let's call it v. Therefore, when t is 2, y'all seen it? Simple things, right? This is making perfect sense. When t is 2, v will have to be 3 by 2 to b squared minus v 4 by 2 plus 1. So this will be whatever that could be. I know toying out from the ice here. So this is 12 minus 8 plus 1. So this is what? 5? 5, how are you looking like? 5? The last thing in this is that you don't want to slip up, do all of this hard work, and forget to pay little meters per second here. You know, units, something important in physics and at maths. So that is it. 2 marks. That's it. Just like I give away a marks. So let's go see the next. Let's go see the next part. What else you have for we there, big dog? All right, the next part is going for 4 marks. So let's see. All right, so this is a next trope. This is a next theme. I hope you're all making note of the ideas, especially the ideas. You're good. You're differentiating to get more complex, like from displacement to velocity. You differentiate. Yes, we can have that math sometime around 7 o'clock. So sometime around 7 o'clock. So maybe I will take a break just now and set the stream. So what is the idea here? The main idea here was look, let me write it in a different color. The main idea for this one was to differentiate and then what? Substitute for t. That's the main idea. That you might see this very same idea in the exam. What's the idea here? When it's at rest, this means if it's at rest, it's not moving, velocity equals 0. No, not integrate. No. This requires you to think about the graph. Think about what you just do. Think about what you just do. We just created a what? A function that was a quadratic. They want you to find out when v is equal to 0. You see where I'm coming from? They want you to find when v is equal to 0. You have a function here. They want you to find when v is equal to 0. Or most likely this function isn't doing that. It's a minimum. It's the minimum function. It is a minimum function. I don't know what this function is doing. Let me graph it out and see. You wouldn't be able to do this in the exam, but I'm just doing this for the sake of explanation. 3 minus 4 and 1. 3t squared minus 4t plus 1. They're using t as a constant, so let me use x instead. X. What they are asking you, ladies and gentlemen, is to find the values of these points. Are you agree? You understand now? Think about it. We just differentiated. We got this. V squared is not v squared. V, the velocity, this is velocity, is always equal to 3t squared minus 4t plus 1. And now they're asking you to find when it's at rest, which is find when v is equal to 0. Put that equal. Anytime you see a quadratic in AdMaths, your spidey sense need to start tingling. Are we going to end up You're very likely going to end up factorizing that solely at some point in time. Very likely. And you know quadratics like salt. It can just appear in any question in the exam. So very likely you're going to end up factorizing that quadratic. So all we need to do to solve this is say when at rest, you're taking note of these points. V is equal to 0. Therefore, 0 would be equal to 3t squared minus 4t plus 1 it was. 3t squared minus 4t plus 1, and you just simply solve this. So 0 is equal to, what is this? This is 3t squared minus 3t minus 1t minus 1t plus 1. So we have 3t into t minus 1 and t minus 1 negative 1. So you'll have either 3t, well, let's just put this first. 3t minus 1 by t minus 1. All of this is equal to 0. So the roots will be either 3t minus 1 equals 0. So this will obviously be t is equal to 1/3, which we saw on the graph. Or t minus 1 is equal to 0. So t is equal to 1. Remember, we saw this on the graph. Now you also need to put seconds. How many of you all remember to put seconds? Yeah, boy. Josh is a man know your thing, boy. You're versed. You're versed in the thing, brother. So 1 second, 1/3 second. And we cooking at Ramco gas day. How are you feeling about that? 4 marks. 4 marks to factorize a quadratic. So the main idea was you're getting a mark for this, you're probably getting a mark for that. Check out your units and thing, and you're getting probably 2 marks to the core of that. Right? That is an easy 4 marks to collect as far as the ad maths paper is concerned. And you already know how everybody here know how to do the quadratic on your calculator, right? I explained that in the algebra session that we did with maths. So you can just look it up on my channel. What's next? What was the next idea that they wanted in this here? The distance between the rest points. The distance between the rest points. What does that mean? Sometimes you need to catch your breath and think. Most of the ideas is simple ideas. It's nothing like sometimes your distance between the rest points and you're beating up yourself. Well, the rest points will be that and that. So how do we find the distance between the rest points? How do we find the distance between the rest points? Well, what is they trying to say there? What is the distance between the rest points, ladies and gentlemen? We can plug it in. We can plug it in. Can do a couple things well. This is a velocity time graph. The distance in a velocity time graph is the area between the graph and the x-axis. I don't want to say the area under the graph because in this case, it sees the area over the graph kind of way. So we can integrate here, but there's an easier way to do this. There's an easier way to do this. We can try to find the distance. We can see, plug in the 1/3, plug in the 1, and find the distance at each spot. Are you understand how I'm coming with it? Because why integrate when we already know the initial formula anyway? S is equal to t cubed minus 2t squared plus t minus 1. Remember, S is equal to t cubed minus 2t squared plus t minus 1. Plus t minus 1. That's the original. And we just found the two values of t at the rest points. At the rest points, the velocity will be 0 when t was equal to 1/3 and t is equal to 1. So at t is equal to 1/3, what's the distance? S is equal to 1/3 cubed minus 2 into 1/3 squared plus 1/3 minus 1. Somebody quick on the calculator, tell me what that is. And at t is equal to 1, S is equal to 1/3 cubed minus 2 by 1/3 to be squared plus. Silliness is what I'm doing. 1 cubed minus 2 by 1 squared plus 1 minus 1. A lot of ones involved here, bro. So I'm waiting on Ali to tell me what that is. I will call this one. This one looking tougher. I will call this one. Why will call this one, right? So this is 1 minus 2 plus 1 minus 1. So we're ending up with here negative 1. Negative 1. Oh, go. And what you end up with here? We end up with another one nearly. Oh, you're not answering me, boy. I'd have it in my calculator right here for everybody. Negative 22 over 27. Are you sure about that? All right, all right. Negative 23 over negative 27. You're going further backwards. Negative 22 over positive 27, right? So negative, nah, it can't be negative 25.20. It's gotta be negative 22 over negative 20. I'm gonna put it in and see. This song then okay, just something like the distance real small. It makes sense that it was like negative 0 point something something, 0.8 or 9 something, and then you go backwards a little more. It makes sense that the distance get increasingly, the displacement got increasingly negative. Why that makes sense is because the graph, the speed in the negative, so you're going backwards. You understand what I'm saying? You was going backwards for a little bit. The speed, you go backwards, and now you're going to start to go forward again. So it makes sense. It makes sense. So the difference has to be the negative 1 minus the negative 23 over 27, which will leave us with negative 4 over 27 meters. The distance between the rest points. So distance between rest points. If you ask me, the last question should have been 3 marks and this one should have been 4 marks because the thought process involved in this one was more difficult. The time at which the maximum velocity occurs. Now, watching this graph, that is highly suspicious. I need to go back and check the question. I need more clues. Trigonometry, I have 2 videos up on YouTube for trigonometry for AdMaths. You can check it out in the meanwhile. A particle moves in a straight line so that the distance s meters after t seconds measured from a fixed point is given by this formula. Determine the velocity when t is equal to 2. Like there's no limit. There's no limit to the madness in this question. Meaning t could go on and on. This is not a maximum graph. There isn't a maximum velocity. The distance between the rest points. The time at which the maximum velocity occurs. Now, if I'm looking at maximum and minimum, yes, you want dy dx equals 0. Everybody programmed to think about that immediately, but let's hear me out. Hear me out. There's no. This is the graph of the velocity as t increases. If I find dy dx equals 0 when v is equal to when the acceleration is equal to 0, I'll find this. I'll actually find the minimum velocity. So let me see if there's any more ideas for this. The value of t when it is at rest, the velocity when t is equal to 2. I have some inclusive ideas on this. Anybody have any thoughts on that one? I feel like CXE didn't think that question through. 2018, I do that question already. I do that question already, boy. See if I do that question already. What question was this? 8. So it really is supposed to be minimum velocity here. I don't know if maybe they got a what they call an addendum on this paper. And I just want to teach you all the concept that usually one time you differentiate and you find when the acceleration is equal to 0. When the acceleration is equal to 0. You all see the graph, right? There's the maximum velocity will occur as t approaches infinity. The velocity will just keep increasing. Now, if they're talking about between the rest points, the maximum velocity in a negative direction is here. Then you could also differentiate. So I would, if you come across something like this, I would put both in the exam. So from the graph, max velocity is when t approaches infinity. But the max velocity in the reverse direction between the rest points. I'm pretty sure CXE discovered this when they was correcting the papers because smart students will think about this. The reverse direction between the rest points is when the acceleration is equal to 0. In other words, when you differentiate v one more time, when you differentiate the function one more time, dv dt is equal to 0. So remember, we already had v is equal to 40 squared. What was it, boy? We already had 3t squared minus 40 plus 1. 3t squared minus 40 plus 1. 3t squared minus 40 plus 1. So dv dt is just going to be 60 minus 4. And then you say when a is equal to 0, dv dt is equal to 0. So you have 0 is equal to 60 minus 4. Bring it across, you get 4 over 6 is equal to t. Therefore, t is equal to 2/3 of a second. And that makes perfect sense because this here was 1/3. This is 1. In the middle of this, can you see that that will be 2/3, which will be there? Making perfect sense. Makes perfect sense. But that is actually the minimum velocity. That is in a negative direction. This is in a reverse direction. This is the lowest the velocity will be. The velocity only gets higher after this. All right, so that was where CXE. Don't do that again. Don't do that in the people them exam. CXE cut that out. Next style of question here on kinematics. Let's look at it. Take a look at this. See what is the general idea we have here. Look at it. Yeah, if somebody send me one paper, I go look at it. So a bus starts from rest at station A and travels a distance of 80 kilometers in 60 minutes to station B. Since the bus arrived at station B early, it remained there 20 minutes, then started its journey to station C. The time taken to travel from station B to station C was 90 minutes at an average of speed of 80 kilometers per hour. On the grid provided, draw distance time graph. Determine the distance from station B to station C. You all could do something like this. Why for yes if you can do something like this? So theoretically, this could sneak into your paper. Yes, it is more mathsy. There's more maths. This could be easy, just as easily be in a maths paper if they're feeling real wicked. They could throw this at a math student. I kind of need graph page for this boy. I hope this is not one of the killer questions, because I just hope you're in it and me that shot. CXE, all in is to me that shot. Do I have something where I could draw on, boy? Let me see if whiteboard feeling up for the task. Oh, it's still there, boy. You're still there from it the other day, brother. It's still there from the other day, holding it down. Well, I feel like I can do it. Maybe I could get my graph page as well. I'll hang in there. You know, watching me draw is the easiest thing in the world. This content is no longer available. Where's that one, right? Draw it without the graph page. So wait it is. First thing I had to do is make a little sketchy sketch. So let me go back to the drawing board and make a little sketch. But start from rest. They start from rest. Travel a distance of 80 kilometers in 60 minutes. What type of graph you want? Distance time. So distance time. So you travel 80 kilometers in how much minutes? 80 kilometers in 60 minutes. So let's put 60 minutes here. Like 1 hour, 60 minutes. They put it in terms of minutes. And 80 kilometers. So we went up to 80. 80 is the highest we've gone up to? Maybe. I throw 80 here just in case. So you do that. To station B. So there's station B over here. Since the bus arrived early at station B, remain there for 20 minutes. So get them a next 20 minutes to reach 80 minutes now. I'm a sketcher, so it's not drawn to scale. It remained there for 20 minutes and started the journey to station C. The time taken to travel to station B to C was 90 minutes. So like for station C, a little further, 90 minutes, and this will be 170. We're going to finish off on. So we're finishing off with a 170 day. And what else? And the average speed is 80 kilometers per hour. So we actually need to do a little substitution to figure out what distance they're going to hit the. So since that distance time graph didn't mention anything spooky, we assuming that it's traveling in a straight line, right? Assume straight line travel or positive distance travel. So meaning it didn't come back down to go to no station, so you just went straight on ahead, right? And you kind of understand the missing concept here. Determine the distance from station B to station C, and that's one of the questions actually. But they wanted you to draw a distance time graph to illustrate the motion of the bus. Draw a distance time graph. But you've seen that we don't know what this is. You all understand that we don't know what this is. So for sure, we're going to kind of do something to figure out that. We're going to have to do a little maths to figure out that. That's the key in this question, actually. So how do we figure out that? Well, we know this is 80. We know it took a certain time, 90 minutes. What's the idea here? This is not CSEC Maths, this is Add Maths. This is not what come in and Maths in Monday. This is for Add Maths students, which is a separate subject altogether. For those of you who just pop in and like wondering what in the world going on. So this is 90 minutes and the speed is 80 kilometers per hour. So we're trying to figure out distance. So it's not that bad. It's a maths question, and math students could do this question. We have a speed, which is 80 kilometers per hour. We have time, which is 90 minutes. So we're going to change that to hours immediately, of course. 1.5 hours. Makes sense? And we're trying to find the distance that will be covered in such a time. Now, speed is distance over time. This means distance is speed by time. All of this pertinent to normal maths actually so far. So distance is therefore going to be the 1.5 hours, and every hour we hitting them 80 kilometers. So this is actually going to be 120 kilometers was covered. So this means this is an additional distance to the, how much we on right now? We are currently on 80 kilometers and 80 kilometers away from station A. But that's not even the question. Determine the distance from station B to station C. We already solved the question there. This is the from B to C. But for the purpose of the graph, we kind of need to know, additional to the 80 kilometers, this will be 80 plus 120. So it's going to finish off at 200 kilometers up. So now when you're drawing your graph, and I'm really feeling to draw that graph, I know only know how to draw this graph. When you're drawing your graph, you know that you will be going. Is there anything else that was pushed in that question? Determine the average speed from station A to station B. I'll do that one just now. So I don't need to do any switches in the graph. So we know that this is going to go up to 200. We'll have something here at about, let's say this is 100, 150. Divide that into 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 80 is about here. This is 100. This is 150. This is 50. You know we're stopping at 80. You know this going up till when? This going up to, you all understanding? Rate out of 10, how much you understanding? 170, 170, 190. Yeah, 170, the 80 plus the 90. 170, this is going up to 170 here. We had 60, we had 80. So let's say this was 60. And this could be about 80. And this could be about 170. So initially, you draw this to scale, of course. It did a straight line to this point, 80, 60. Then it stayed still for 20 seconds. And now we know it would have gone all the way up to 200. We worked out the maths behind that. So the graph that I'm expecting is this. Making sense, everybody? That's the graph that I'm looking at. So take a look at it, make sure you understand. You see the sketch, you see the idea? Determine the distance. I did that already. I needed that to find out the graph, how to do the graph anyhow. The last part of the question wanted us to determine the average speed from station A to station. All of this real, I should not even do this question. It's too easy for an math student. The last part of the question wanted us to determine the average speed from station A to station B. Average speed, and remember this is A and this is, so this is A, this is B, and this is station C up here. You would put your labels, you'd put your velocity, distance, time in seconds, distance in meters or kilometers actually, and graph of blah blah blah, and you pay a scale here as usual, right? So they want us to, yeah, I hear English was sweet. Pure maths. When is pure maths unit 1? When is pure maths unit 1? If Ms. Nalini have enough time to do some, to squeeze in something, but they want us to determine the average speed here, which is cake and ice cream thing. So average speed What is the formula for average speed? Yeah, I know you're thinking, Ramiro, that question was in somewhere 2014, 2015, 2016, somewhere around there. That was a murderous question. So average speed is the change in distance or total distance over time, right? And that distance was, I don't know what kind of easy question is this. 80 divided by 60. The only thing is we have to remember to change it to hours. So it's 80 kilometers per hour. And that's the end of that. If that come in your exam, well, bro, they love all you. I doubt they bring in something that easy in an maths exam. They're not going to bring that again. That was actually in an maths exam, but that was when they had the paper split and things. So they used to go sweet Italia. Let me try 2019. I really want to get to this year. So hopefully we have time to do this. No, last year. That'll be where if we pull out this year paper and do it. I want to get to last year's paper. So standby faction. Let's do 2019 and see what is up. If it's this question, I don't want to do the graph part. Let's do the particle part then. Not graph part, too easy. But yes, you need to understand your motion graphs are maths for sure. Just in case. Just in case. So so a particle moves in a straight line such that t seconds after passing a fixed point O, the acceleration in so they gave us the acceleration. Back to the original thought process for these kinematics question. What happens here? Moonlight Wolf, I love you, sir. I love you too. No Diddy. The values of t when the particle is stationary. So what kind of idea is happening here? Stationary always mean velocity equals 0. We have velocity? No. What we need to do, boy? What come into mind? Stationary mean velocity equals 0. It's not moving. What are we going to do? What idea y'all thinking about? We have A is equal to 12t minus 17. You have some other talk, blah, 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 blah. You have some initiation talks here, what I call initial parameters. We need to integrate, because if we start off with acceleration and we need to simplify and go back down to velocity, that's an integration. If we started off with displacement and we need to go this way to velocity or to acceleration, that's a differentiating. Coming back down is integrating. Simple as that, you know. Now, there's one trick to always remember when you're integrating. One vital trick. In fact, I am sure it coming in your paper. What is one trick to remember when you're integrating? Not how to integrate. I talk more when you're integrating this thing. What is one thing to always remember? What is one thing to always remember? That. You always have to remember that. You have to stay paranoid. You have to stay paranoid about the constant of integration. Paranoid about the constant of integration, especially in this question. Especially in this question. So I integrated this, I get this, which is really, let me just make sure. Yeah, 60 squared minus 17t plus c. That's what my velocity is. You have to remember that in this question, because you just had to get rid of it. The whole idea with these integrating in kinematics is getting rid of the c. You just had to get rid of the c, and there's only one way. There's one way that you always get rid of the c. What is the way to get rid of the c? How do you get rid of the c after you integrate in these tactical questions, these kinematic questions? What's the one way to get rid of the c? You have to remember this in the exam. It's going to come guaranteed. That's that. If the integrating part comes, you use your known values. Usually, is initiating values, initial values. You use known values. Given that its speed is 10, okay, a particle moves in a straight line that t seconds after a fixed point O, its acceleration, we use known values. It's given by that. Given that its speed is 10, determine the values of t when it's stationary. Now, it didn't say it start from rest. It didn't say it start from rest, which is strange. Did it say it start from rest? Particle moves in a straight line, let's just see after. Usually they'll say they start from rest. Okay, given that its speed at O, a particle moves in a straight line such that t seconds after passing a fixed point O. So it's like this, and it passed O, and its speed was 10. So immediately after it passed O, or while it passed O, the speed is 10. But usually they say it start from rest, so Z is input 0, 0. But in this case, you pass O, so that you just pass O. That means you're at O, your time is 0, right? Because that's when you just pass O. T seconds after you pass O. T at O. That making sense? That's a little weird. That's a little unorthodox. At O, T is equal to 0 and V is equal to 10 meters per second. So you need these values to plug in to get rid of the C. You need these values to plug in to get rid of the C. Agreed? A particle moves in a straight line such that t seconds after passing a fixed point O. So the particle just passed O, but it already zoom in at 10 meters per second, which is some good speed day particle. So what I'm saying is usually they say the particle starts at rest. So you know that V is equal to 0 when T is equal to 0. So, okay. So if we substitute V10 is equal to 6 by 0, so V squared minus 0, 17 by 0 is 0, plus C, it turns out that C is just 10. And that 10 there is in meters per second, but we don't care. That is just our C. So the values of T when the particle is stationary. When particle is stationary, V is equal to 0. So therefore, 0 is equal to 6t squared minus 17t plus 10. And you can factorize, you could use your calculator and just bust through this. So 60 was that 3 by 20. So what we dealing with a negative 60 and no, I need positives. I need positives, boy. 60 is negative 17 I have here. T squared minus 17t plus 10. 6t squared minus 17t plus 10. Let me turn on the light. Yeah, this is 2019. 60 squared minus 17t plus 10. Yeah, this feels like I didn't make any mistakes. Values of t. Solving, you get t is equal to 2 and t is equal to 5/6 seconds. Wait. That thing follow me? Oh, I thought I didn't see my room. T is equal to this. But 6, 10, 20, 60, 11, 15. Three. What's the factors here? Backtrack this and see the factors. T minus 2, 6t minus 5. Minus 12 and negative 5. 5 12s. 6t squared minus 5t minus 12t plus 5 by 12 is, yeah, plus 10. T into 6t minus 5 minus 2 into 6t minus 5. So give me t minus 2 and 6t minus 2. Yeah, I wasn't seeing that for some reason. 6t minus 5. So yeah, we got to go. The values of t when the particle is stationary always had to be on the lookout for negative values here. None of the values were negative, so this works. This question still gave me the heebie-jeebies. The values of t for any particle is stationary. We have this, we differentiate v, no mistakes were made. C is 10, substitute. Equator 0 when velocity is 0. T is 2, t is 5/6 seconds. Yeah, solid. 20 and 3. No. Both had to be negative. -5 and -12. Yeah. All right. Next question. So I wasn't seeing that for some reason. Maybe I don't know, tired of. So I worked it back out from the answer. The distance that the particle travels in the 4th second. This question stated badly as well, too, boy. The distance the particle travels in the 4th second. So I know what they want, but the question stated kind of weird here. Boy. They want distance, they want us to go down to distance, right? But the distance the particle traveled in the 4th second. What I mean, the distance it travels up to the 4th second, maybe is a better thing. Up to the 4th second. But the general idea is that okay, you're going to integrate, you're going to substitute initial parameters, initial values. You're going to find for C, use it to solve. Either it might be a quadratic and you'll have to get 2 answers, or you just get straight up, get the answer, whatever. If you want to go even further down into displacement, integrate again. And that's what you want to do. You want it to go, and there's real mixed the words here. Sometimes they're saying velocity, sometimes they're saying distance, displacement. There's be real careless with it. Physics students, you don't have such privilege. The distance the particle travels up to the 4th second. So right now we at v is 60 squared minus 17t plus 10. This is what we had with v. So we need to integrate this again to get to distance. Let's call distance s still, right? Distance s. So s is equal to integrating v with respect to t. Once again, we're going to end up in a situation. sorry, we integrating, so we're going more complex. So you're gonna end up with a situation where we have a next C. Could call him C2. And what do we do in this situation? This is 2t cubed minus 17 and 2t squared plus 10t plus C2. Yes, it is possible to integrate one time between the limits. But because the first thing is 0, it's not like it's going to be shorter that way. You're going to actually be longer. You're going to have more writing to do. Maths will be 7 o'clock. Sorry, Nalini. 7. I'll start maths around 7. So what's going on here? We need to get rid of the C again. Here we are with C, and we need to get rid of the C. Well, we need to go back to the drawing board. This is after it passes O. So there's this fixed point O, and it passed O, clocking 10 meters per second one time. But at that part with O, S was also 0. S is 0 and T is 0, which is usually the case in these questions. So this is S. So you'll say when S is equal to 0, T is equal to 0. So everybody here is 0. So everything is going to 0, and you get plus C2. So therefore, C is equal to 0. Now you might be saying, okay, well, find C2 not to be 0. It wasn't detrimental. But this is actually a mark in the exam. You have to, I would say maybe more than half of the times the C is just boil away to 0. Because it'll be 0, 0. So, and these terms all have a variable in them. So it just goes 0 here, 0 there. So C is just turned into 0. But you still need to show the working because look, this time C did not turn into 0. So C is 0. Therefore, the distance S is equal to, back to my red pen, S is really equal to 2t cubed minus 17 over 2t squared plus 10t. So what next? We will be like, when t is 4, now I could do all of this straight in my calculator. I could integrate this, which is between 0 and 4 in my calculator, and get through it. When t is 4, what are we going to get? Somebody who quick with the calculator, tell me. 2, 4 to the power of 3 minus 17 over 2, 4 squared plus, I don't know, that space, 10, no, 4. Hopefully we get something nice here. That making sense? It is a cubic polynomial, so that distance could be doing all kind of wildness. That particle could be going forward, backward, all kind of thing. 32, clean, a clean 32. That's fantastic. 32 meters, 6 marks. Well, it ain't giving you that kind of marks for these kind of questions again. All right, so that was that. That was 2019, which also was a little weird. I think the person who's come up with these questions is like probably struggled to get the wording behind the question properly. Let's look at what happened last year. The stationary point. Then we had a graph to draw with a drone, and this copy that I have here in shambles. I could just show it from a distance, and then we can start to go through what to do. You might be seeing anything there. This is the graph idea, so which is easy. A drone tracks the motion. So all right, there's this big graph underneath here, right? I'll have to show you. I'll have to do the graph on the other spot. But let me just focus on the question for now. So let me see if I can make the question itself big. Right? A drone tracks the motion of an object in motion on the ground. The following movements are recorded. Right, so it's a drone and thing. CXC alias stealing my question ideas there. I never used to talk about drone. My questions, you start drones in it, and all of a sudden it's a drone now. It moves at a constant velocity of 4 meters per second for 5 seconds. Its velocity increases uniformly for 3 seconds to 10 meters per second. It moves at the velocity for 7 seconds. It moves at that velocity for 7 seconds. It slows uniformly. Blah, 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 blah. Sketch the graph of the movement of the object. And what they had on the graph, what they had, velocity time. So it's a velocity time graph. All right, so let's do some sketching out some ideas here. Velocity time. And let's see, most likely something is missing and something needs to be calculated. Why isn't it chat if you feel you could do this? Somebody say it was food. So most likely something is missing and needs to be calculated. So it moves at a constant velocity of 4 meters per second for 5 seconds. Wait, just now. Let me see, that's the intro. Once again, you had to do some kind of weird assumptions in this. The following movements. So it begins. It moves at a constant, so it begins and it moves, right? It moves at 4 meters per second for 5 seconds. So we're assuming that they mean this. Is it going to increase velocity? Yes, it increases, moves, slows. Okay, so they put 4 like about here because you know it had to increase after some time. So this is 4, and it did this for 5 seconds. Already in my mind, I'm starting to see like maybe we might have to find the distance traveled here and that kind of thing, which is the area underneath the graph. So this is velocity, and this is in meters per second. I believe they wanted this, and this is time in just normal seconds. So everything is good so far. Its velocity increases uniformly for 3 seconds to 10 meters per second. Oh, look, they have it here, 10 meters per second. So we know we're going up to 10, and it increased for 3 seconds. So far, everything looking easy. It's starting to look a little too easy. So let me just go back and make sure nothing is happening where a drone tracks the movement of an object on a motion in the ground. Following movements are recorded and moves at a constant velocity. Let me check the units that they had. They didn't give us the units. Oh yes, they did, meters per second and seconds. So nothing in wrong. Nothing in wrong so far. All right, fine. Little scary. 3 seconds down the road, it going up to 10. Die with it. It moves at that velocity for 7 seconds. 8 plus 7, 15. My math wasn't mathing just now, so praise the Lord, it's that back. 8 plus 7 is 15 right here. So then it slows uniformly and it comes to rest. Comes to rest means 0. 4 seconds. 19. I cannot believe it. We get to draw the whole graph without having to figure out anything. They're really softening the blow on these kinematics questions, boy. How many of you all do kinematics question from since like 2012? And math start in 2012, 2011, 2012. That was too easy. So normally there might be the acceleration or something, and then it reached it. And you had to figure out this, or something had to figure out, but you get to draw the whole graph clean. Go. If you want to see real question from question land, I believe it's 2014. Go back and look at 2014 and meditate upon it. I do it on YouTube a few times already. It slows uniformly until it comes to rest after 4 seconds. How much marks they give me for this last year, boy? Last year, how much marks will they give me for this? Because what in the world is that? 3 marks. 3 marks for maths things. Anyhow, so you make sure you pay a scale. Usual thing, right? You pay a scale here. You put your title. Make sure they already labeled it for you too. Like what in the world? And they give you the graph. So this 3 marks will come by too easy. That come by too easy. It's scary. Let me see what maybe they're going to hit with a big question afterwards. What is next? The calculated distance traveled by the object in the second part of the journey. What is the second part of the journey? You see this kind of vagueness in the questions is what I do like. What is the second part of the journey? A let's call this the second part then. Maybe that's what I mean. This is the first part and this is the second part. It moves at a constant second part. Let's call, maybe that's what I mean by parts, right? That's logical to think that, right? A drone travels at that, the following, so they want the second part. The area under a velocity time graph is always the distance. So it's as simple as finding the area underneath that. This is the area under the graph from t equal 5 to t equal 8. Other ways to do it is to find the equation of this line and integrate. Or there's other ways to do it. S is equal to half ut plus half at squared. Other ways to do this. Find the average velocity, then find the time taken. So in other words, it's almost like a change it into a rectangle. And I find the average velocity. So in between 10 and 4 is, in between 10 and 4 is what? 7? 7. So it's really 7 by 3? 7 by 3. Oh my lord, it's too easy. So anyhow, area underneath the graph from t equal 5 to t equal 8. So that is half the sum of the parallel sides by the height, because it's a trapezium, or by the distance between the parallel sides. So this was 5. No, that was 4. That was 10. 4 and 10. And then we had 3 here. So it's half of 4 plus 10 by 3. So 7 by 3 is 21 meters. Calculate the distance traveled by the object in the second part of the journey. It's not feeling right, boy. I'm feeling the usual pain that is come with this question. I should have do these questions before the live, because when things happen so easy, I'd be like, mistakes, boy. Calculate the distance traveled by the object in the second part of the journey. I just double checking everything that I do, people, right? Because I want to leave this video up and I don't want it to have any glaring errors. That's the second part of the journey, right? It went to 5 seconds to 3 more seconds, so that's 8. Yeah, boy. Yeah. Looking good. Looking good. Let's carry on. Let's press. So calculate the distance traveled by the object. The next one was determine the acceleration in the final part of the journey. I do not believe this. What is this? Well, you're praying for something like this, for it. And let me stop saying that before the people who is make up the questions here and me and decide to bring fire for them next year. Yeah, George, I wondering what really going on here. I feeling the heebie-jeebies. How 4 plus 10 is equal to 7? Half of 4 plus 10. Half of 4 plus 10. Zalia. This is the area of a trapezium. Half the sum of the parallel sides by the distance between them. All right, determine the object's acceleration in the final part of the journey. So, acceleration and exceed, pretend you see an exceed, is change in velocity and the time it takes you to make that change. So if you're seeing change in velocity, this is velocity, the time, is really you're finding the gradient. You're really also finding the gradient there, right? But we could use this idea, like final velocity minus initial velocity divided by the time it takes for that to happen. So let's go look at this. I'm seeing 10, and then it went down to 0, and the time it take for that to happen was 4 seconds. So it kind of makes sense to just use this formula and then write 10 minus 0, and the time was 4 seconds. What is this question? 2.5. I seen a Lini just now. Lini, you double check this question, right? I need the question as this point. 2.5 meters per second. That was this year. And that's what I wanted to do this year. I was expecting it to take some time. All right. And let's put negative here to secure the bag. Negative 2.5 meters per second, since is it going is really 0 minus 10. It's really 0 minus 10. Or 2.5 meters per second in the reverse, meters per second squared in the reverse direction. What do you think? Yeah, I'll leave it up. I'll leave it up. So that was this year. I believe there's another part. So this was tagged along to the question 4, and tag along to question 5. We expect to see the kind of integration vibe question. Nice. This question looks like it have a little more juice in it. Let's load up a new board. Let's load up a new board there. Like, give me a little chance. So it have a toy truck hunting in this question. All right. Yeah, so always be suspicious when things come too easy. That like you could be kidnapped, feeling like a ice cream truck somewhere nearby. What is all this ice cream? Assume that the speed of the toy truck is measured in centimeters per second. Consider a toy truck moving along a miniaturized racing course with an acceleration. So we have acceleration as a function of t. Great. Outline how an equation for the speed of the truck would be found using the given equation. So they basically asking you what is the step is using these kind of questions. So no initial variables was given. We have no initials. I'm going to go and snap the next part of the question and put it in one time. Doop, 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 doop. Da, 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 da. Doop, doop. Once again, it has no initializing here. So, like, there's always an initial thing that's supposed to be given. Like, when time is 0, the velocity is 0. Or last time, it was strangely 10. The reason why we have these initial values is to substitute and get rid of the c when we integrate. So the first step is to integrate, what they call it, with an acceleration, integrate a with respect to time. So the velocity or the speed, they use the word speed here. The speed is going to be equal to the integral of at with respect to time. It's only one mark, so I think that's all I want. But the next steps we know from the question is to substitute initial values to get rid of the c, to figure out what c is. What's going on in light by? All right, well, let me see where this question is going to lead us. We have 9t squared plus 2t minus 1. So we have 9t squared plus 2t minus 1. That's acceleration. And we're going to integrate this and end up with velocity or speed, right? So we get 9t cubed. Thank you for making this 9, so we get some nice canceling there. Thank you for making this 2, so we get some nice canceling there. Very nice of you, CXC, to do that. I see you doing that these days, and I CXC. Keep it up, keep it up. So we get 3t cubed plus t squared minus t. But there should be a plus c here. And because nothing was given, I go in and just assume, bro. I assuming that when t is 0, v is 0. I go in and assume. Now understand, you know I'm going and slip up with that C and this. And this noisy scene, boy. You know I'm going and leave out that scene. Never, never, never again in life. So assume the speed, love and blessings. Assume the speed of the toy truck. Outline how equation for the speed of the truck will be found. I'm assuming. So when t is equal to 0, v is equal to 0. So 0, 0 plus c is equal to 0. So the next part now, I'll have v is equal to 3t cubed plus t squared plus t. That was it. Minus t. Sorry. Minus t. When, and it's suspicious and random. I sure all these students who did maths back in 2014, 2015 was watching last year and just vexed. When t is equal to determine the velocity when t is equal to 10. When t is equal to 10, v is equal to 3 by 10 cubed plus 10 squared minus 10. At least they're still bringing the trigs and things. They're still bringing the trigs clever. So, what is this? 3,000 plus. Somebody work out this for me now. 100 minus 10, 390. So fast. Meters per second. And t is equal to 0. When t is equal to 10. All right. So somebody said they don't understand. Why am I to repeat over? Take a look at it. Watch which lines you have problems with. What paper was this? This was. Is there anything more in this question? Oh no, there was something more. All right, now I talk more. Find the distance covered by the truck. Express your answer. Nice, nice. We love to see it. There's something more here. What are we gonna do for this? I'm gonna repeat for the person who doesn't understand. Um, just a second. Did you find the derivative of v? Did you find the derivative of v? Why would I find the derivative of v? Where my mouse? Yeah, so the best thing to do, especially in a situation like this, if it's a toy truck moving along a miniaturized racing course, it's fairly logical to see when t is equal to 0, the velocity is 0. We had to get rid of the c somehow, so I had to make that assumption. Now, the same thing applies in all these questions, where you have acceleration as a function. You're trying to get the velocity, so you have to integrate with respect to time. So we integrated, but every time you integrate indefinitely, you introduce a constant, the constant of integration. And you must figure out a way to get rid of that. So it wasn't given, but usually they say it started from rest or something like that, which means when t is equal to 0, v is equal to 0. So you substitute all these zeros for the t, you substitute 0 for the v, and c is equal to 0. What you're not understanding here? George, Dynamo house at our background. I mean, your houses look kind of good too. But Dynamo house at our background. So c is equal to 0. The reason, when we get c is equal to 0 now, we could just use this formula now without the c. Yeah, man, bless up. I hear paper 3 earlier manager, seen it in the PC group. So when t is equal to 10, we just substitute. Yeah? And we get the velocity. Y'all could play it back. Let's go and look at the last. Let's go and look at the last part. Let's go and look at the last part. You understanding now? Find the distance covered. So we remember we have already v now. So they're talking distance. So what's the next logical step? The next logical step, find the distance covered between then and then, is to integrate. Now this one, that's not. Let me see if this was between. Nah, this wasn't between. This one we don't need to worry about constant of integration because we go in between 5 and 10 seconds. So the constant of integration will remove itself. So we don't need to worry about initial values. In other words, what I'm saying is we integrating the velocity between 5 and 10. Yeah? You understand what I'm saying there, class? You're integrating the velocity between 5 and 10. And as said, you could do this on your calculator. Let me show you all for those of you all who never see me do it. You can use this function. Instead of t, I use x, right? Of course, because you see I have dx there. So we use 3 alpha x cubed plus alpha x squared minus t minus alpha x. Put in your limits between 5 and 10 and hope that your calculator get the right thing. You get this. You get that. Is that the answer? Somebody who know the answer? I should have worked out the questions before. Is that the answer for this question? So yeah, that's how you do it on your calculator. So you could practice. Those of you who know how to integrate and thing, you could practice using your integration on your calculator. Definite integrals, definite differentiation too could be done when you know where x is. You could differentiate something if you know what the x value is going to be. So express your answer. So what we really want is to integrate this between 5 and 10 respect to t. So this will end up being 3t to the power of 4 all over 4 plus t to the power of 3 all over 3 minus, wait, what am I doing? I am integrating, yes, t to the power of 2 all over 2 between 5 and 10. And you substitute the 10, you substitute the 5, and you subtract the 2 from each other, which is kind of tedious for me to do right now. I'm ready to close up shop. So I guess the biggest thing that they're making you do these days is just annoying you with this kind of working. And again, you could double check this on your calculator so you could know whether you're making any mistakes in the arithmetic here. This was last year. Yeah, before wasn't that bad either. I didn't take my time to look at last year questions in depth. I think I did the solution for it online already though. But I just jump off the bed and do this live. So this is like the hardest thing for you, which is just arithmetic, substituting and making sure you don't make any mistakes. So I'll leave that part up to you. You're supposed to get this answer here. Or you can get it like this. 7, 2, 8. Now make it into a mixed number. Shift 7, 2, 8, 5, and 5 twelves. 7, 2, 8, 5, and 5 twelves. So this is what we're looking at. We need to put meters, of course, because we want to secure we max. What next are you want me to do in add maths? I'll want to look at some circle geometry. When is the add maths exam? So up next, 7 p.m., I'll jump back out for maths. We want to look at completing the square and stuff like that. maybe even go further into other things. And all you want vectors for add maths, vectors for add maths. If you think vectors for add maths hard, you're overthinking it. Vectors for add maths is one trope over and over and over again. Probably I look at the circle geometry for add maths, which is a little different. Completing the square for add maths. You're looking at completing the square for add maths now. You have plenty of revision to do, bro. Crash course. Yes, I have a crash course in add maths coming up. It's a 12-hour crash course. Those of you who want to jump in that crash course, it's 300 TT. 868 plus 1868 3101306. WhatsApp this number now. And jump in. They get the whole rundown on how to get into that crash course. Stats and probability. Statistics. I don't think there's too much difficulty in statistics. Standard deviation. Statistics is a lot of theory to memorize. Probability. Probability has some tricks. Could probably pull in some probability. 300 TTD, 300 TTD. $300 or 7,000 Jamaican for the Jamaicans. Trigs, I know people is always request trigs. So what y'all can do, I have lots of stuff on YouTube right now. The live about to shut down. But search Kerwin Springer, add maths, and search whatever topic you want. I don't have much as it not as maths as well covered as maths, but definitely trigs. I have really good stuff on trigs. Like y'all could watch the whole work thing that I have on trigs and learn it from maths into add maths, and even pure maths students. You can get some pure maths as well on trigs. It goes all the way up to pure maths. So trigs, I really trash out trigs on YouTube. Yeah. All right, Talia. Love and blessings. Look up this. Look up this right now. Press like on the stream. Dive out. Make sure you press like. Make sure you subscribe. See if you're jumping in the stream later for 7 p.m. Let me know. Well, I'll see you there. Love and blessings.